Hello everyone, welcome back to the Aspen channel. For those who haven't subscribed yet, please do subscribe the channel and watch the previous videos. In our today's exercise, we will be doing flash calculations in Aspen HYSYS. So objective of our today's simulation is to investigate vapor liquid separation at different operational conditions. The initial conditions given to us that we are given a binary mixture, benzene and ethanol, which is an equimolar mixture. The pressure of this mixture is 1 bar, initial temperature is 25 degrees centigrade, and flow rate is 1 kg/mol per hour. And definitely we have to select a property package, appropriate property package. Already we have discussed this package in our lecture number 5. I'm giving its link in the description and it will be showing to you in suggestions right now. So let's start Aspen quickly adding the components benzene, ethanol, and I am selecting the fluid package NRTL. Scroll down and select NRTL. Just for a hint that this is a chemical system at low pressure. So if you remember, for chemical system at low pressure, we can either choose NRTL, Wilson, or Uniquac. And you can check method assistant to verify that we have selected a right property package and it's also turned green. We have given done this part. Now flash calculations have to be done using a heater block, and we have been asked to do 5 different flash calculations named as PV flash, TP flash, TV, PQ, and TQ flash. Pressure, vapor fraction, given value of pressure is 1 bar and vapor fraction is 0.5. In TP flash, pressure is 1 bar and the value of temperature have to be taken from this condition number 1, which is the PV flash. In TV flash, the value of vapor fraction is 0.5 as that of first condition, and the value of temperature has to be taken from PV flash, means the value which we calculated here has to be taken in this and has to be taken in this point as well. Similarly, in PQ flash, P is equal to 1 bar, take the value of Q from PV flash, first condition. TQ flash, take both these values from first condition, which was the PV flash. So we will be performing 5 different flash calculations using a heater block in the system. I will quickly add the corrections of heater block here. So as you see, connections have been completed. 1 is the inlet, 2 is the outlet, and Q is the energy. We have already discussed the connections in our video number 2 as well. So going to worksheet, the initial condition is 25 degrees centigrade, 1 bar, 1 kg/mol per hour, and the composition is equimolar, means for benzene it's 0.5 and for ethanol it's 0.5, and click OK. Now to simplify this, I have created an Excel sheet for me in which all the 5 conditions have been given: PV flash, TP, TV, TQ, and PQ. So first case is that we are given a vapor fraction of 0.5 and for pressure we are given 1 bar. So we will go to this one heater block, and as you know, the degree of freedom of for heater is 2. So 1 bar and 0.5. And as you see, you have got the answer of temperature, which is 67.03, and heat flow, that is 5648. So simply what you do, you have to copy it and place it in Excel sheet. So as you see, temperature is given over here 67.03, which actually is 67.027 something, on which is rounded off as 67.03, and 5647.94 kilocalories per hour is our Q. This is the first condition. In second condition, which is the TP flash, we have to use the same pressure as that of condition number 1, but now temperature from first condition, means 67.03. So what I will do, I will copy this value from here and I will paste in Aspen HYSYS. So what I will do, now it's TP, so I will delete this value V and I will simply control V, and as you see, the value has been pasted over here, which is 0.5099. It's slightly higher because I am using value over here 67.03. If I use value 67 point this value, then as you see, it's exactly 0.5. So it's up to you. You can use round off or you can put all value over here. So again, putting back value in, as you see, 0.5 is the vapor fraction, 67.03, 1 bar, and 5647.97. In the third case, as you see, Q is almost same. In the third case, it's a TV flash. Now have to use V as zero point 0.5 as we used in condition number 1, and here in temperature we have to use the same value as we got in condition number 1, which is 67.03. So putting the values in Aspen, what you need to do here, you have to delete pressure and you have to enter zero point 0.5, and you see it's again 1, it's again 5648. So putting values in Excel back, and you see again the value of Q is nearly same. There is no difference. There is no difference in pressure. The temperature is computed from condition number 1 in these both cases, and you see vapor fraction is also same. In the TQ flash condition number 4, we have to take temperature from condition number 1 and we have to take Q from condition number 1. So what I will do, I will take values from here and I will paste over there. Control C copy and Control V paste. So I will simply delete zero point 0.5 from here and I will paste the value of Q, which is 5648, and you see 0 0.5 and 1 bar. So I will again go back to my Excel sheet. 0 0.5, this was the same, 67.03, and this was here as well, and the pressure is 1 bar. In the last case, it's PQ flash, that you have to take Q from condition number 1, which is already in our heater block, and you have to change the value from temperature to pressure. So remove it at 67.03, write pressure as 1 bar, and you see again you are getting the same answer. So simply copy paste it over here. As you see, the values are still the same and it's 0 0.5 bar. So that's how we do the flash calculations in Aspen HYSYS, and as you see, we have simulated the 5 different cases of flash calculations. Let me elaborate it more. I have simply yellow highlighted those figures which were specified or which were given in the problem statement, and I have orange highlighted those figures which were computed from the simulation. As you see, in every case there are two values that are yellow highlighted and two values that are orange highlighted. Obviously degree of freedom for heater is 2. So we have specified two values and we have calculated the two values in each case. So this is how flash calculation is done. In our next video, we will learn how to calculate heat of vaporization for different components. So please watch the video, like the video, and subscribe the channel. Till then, it's goodbye.